You're sitting there staring at a blinking cursor in a sterile testing center,
Yeah.
and you're just trying to remember if the command line flag you need is like a lowercase r or a capital R.
Oh, yeah. The absolute worst feeling.
Right. And for decades, that was basically the reality of technical certifications. They were effectively a test of your brain's ability to act as a poorly optimized relational database.
Which is a model that completely falls apart the second you introduce AI into the software development lifecycle. I mean, the moment you have a tool that can instantly recall the entire syntax of every programming language on Earth, rote memorization is just obsolete.
Exactly. We're not testing recall anymore. We're testing orchestration,
Yeah.
right? Like judgment and how well you manage context.
Yeah, that's exactly it.
And that is exactly why we are dedicating this entire deep dive to you, the learner, to help you crush the official Microsoft exam for GitHub Copilot. That's the GH-300.
It's a beast of an exam, too.
It really is. So we've pulled together this massive stack of official Microsoft Learn documentation, architectural diagrams, security white papers, all of it.
But we aren't just going to sit here and read a list of features to you.
Right.
That won't help you pass the GH-300.
Right, because reciting bullet points is just, well, it's boring for one.
Yeah, and the exam is designed to validate whether you actually understand the underlying mechanics of these systems. We need to explore the exact architecture,
Like how a prompt is securely routed.
Exactly. Or why an autonomous agent consumes specific compute resources and how these tools actually integrate into an enterprise-grade environment safely.
Okay, let's unpack this. We're going to trace the entire lifespan of a piece of code, starting from the exact millisecond you stop typing in your IDE, all the way through local testing, terminal debugging, merging on GitHub.
And finally, how an enterprise chief information security officer actually governs that entire process.
Yes. So let's start at the absolute micro level. I am in Visual Studio Code. I'm typing out a comment for a new Python function, and I pause. And then, like a millisecond later, Copilot offers me this block of gray text. How does it actually know what I want?
Well, it all begins with a mechanism called fill in the middle, or FIM.
FIMO.
Yeah, FM. This is the foundational context gathering technique you absolutely must understand for the exam. When you pause your typing, Copilot doesn't just look at the line you're currently on.
I mean, if it only read your current line, it would have no idea what dependencies you've imported at the top of the file, right?
Exactly, or what variables you've defined below your cursor.
Right, so if I just type #calculate total, it needs to know if I'm calculating a shopping cart total using floats or like a database aggregate using SQL.
Precisely. So FM acts as this highly intelligent parser. It tokenizes the code, basically breaking it down into machine-readable chunks, and it specifically gathers the prefix.
Which is everything before your cursor.
Right. And the suffix, which is everything after your cursor, it weaves those together to give the large language model a complete picture of the file's current state.
But wait, what if I'm writing a function that relies on some massive data schema defined in a completely different file? Just reading my current file isn't enough, is it? Does am look outside the window I'm working in?
It does, yeah. And this is where it gets very sophisticated. FM casts a really wide net across your IDE environment.
Okay, what does it grab?
It gathers the file name you are working in, the file type, your project's directory structure, and crucially, it looks at the adjacent open tabs in your editor.
Hold on, let me stop you right there.
Yeah.
I am notorious for having like 40 tabs open in VS Code.
Most developers do.
Right. So is it trying to bundle up thousands of lines of unrelated code from a tab I opened 3 days ago? Because wouldn't that just exhaust the token limit of the model and completely confuse it?
That's a very perceptive question, and the answer is no. It doesn't just blindly grab everything. FAM uses a relevance heuristic.
Meaning it guesses what's important.
Essentially, yes. It prioritizes the tabs you've interacted with most recently. It also looks for semantic similarities. So if you are working in a Python file, it will prioritize other open Python files over, say, an open Markdown README file.
Oh, that makes sense.
Yeah, it intelligently trims and weighs this context so it fits perfectly within the token limit of the prompt. That ensures the model only receives the absolute highest signal information.
Okay, so FEMEM is essentially packing a very specific, highly optimized suitcase of context for the LLM.
That's a great way to put it.
Now, here is where my fintech background kicks in and where I start getting a little paranoid.
Uh-oh. Let's hear it.
VM just bundled up my proprietary auth logic, my internal file paths, my surrounding code, Where exactly is this data going? Please tell me it isn't just being blasted out over the open internet to a public ChatGPT endpoint.
Right, so security is a massive domain on the GH-300. Let's trace the exact routing of that data. Once FIM builds the prompt locally on your machine, it encrypts it and sends it via HTTPS.
Okay, standard encryption. Good.
But it does not go directly to the raw OpenAI models. It is routed to a dedicated, highly secure proxy server.
Wait, where does this proxy live?
It's hosted within a GitHub-owned Microsoft Azure tenant.
Ah.
And this is a critical distinction for the exam. Microsoft and GitHub control that infrastructure boundary. When your data hits that Azure proxy, it acts as a very strict security checkpoint before it ever touches the LLM.
So it's like airport security from my code.
Yes, perfect analogy.
My IDE packed the suitcase using Phonem. The HTTPS connection is the armored car taking it to the airport. The Azure tenant is the airport itself.
Right.
So what acts as the metal detector?
The proxy filtering mechanisms are the metal detectors, and there are actually several layers to it. The first layer actively scans for malicious intent.
Like what?
It blocks prompt injection attacks. Basically, attempts by a user to manipulate the system into ignoring its core instructions, or maybe revealing its internal system prompts.
Are developers really trying to hack their own autocomplete?
You'd be surprised. But more importantly, the system has to protect against toxic content. Before intent extraction or code generation can even happen, the prompt passes through a toxicity filter.
So it's looking for bad language.
Yeah, the proxy uses specialized classification models to detect and block hate speech, offensive language, inappropriate content, all of that.
And what about data privacy? Say a junior developer accidentally hard codes an AWS secret key or like a customer's social security number into a comment and then triggers Copilot.
That brings us to the next layer of the proxy, the personally identifiable information, or PII filter.
Oh, thank goodness.
Yeah, the proxy actively scans for and strips out sensitive data patterns, social security numbers, credit card formats, standard credential patterns before the prompt is processed by the model.
So just to recap the timeline of this single millisecond I pause,
Well,
AVM gathers the prefix, suffix, and relevant open tabs.
right.
It encrypts it. It hits the Azure proxy. The proxy blocks hacking attempts, filters toxicity, and scrubs PII. Only then does it hand the sanitized context to the LLM to generate the suggestion.
That is the exact secure pipeline you need to understand for the test.
Wow. Okay, so if the LLM's entire output is based on the suitcase of context that FIM packs, that means my main job as a developer is to make sure I'm giving FM the right materials to pack.
Precisely. Because Copilot is fundamentally a stateless system between interactions, mastering the input is the most critical skill for a developer today.
So prompt engineering.
Yes. The GH-300 dedicates a huge portion of its material to prompt engineering.
And our sources highlight a very specific foundational framework for this called the 4S method. Let's break this down because it honestly sounds like the cheat code for getting exactly what you want out of the model.
It really is. The 4S method stands for single, specific, short, and surround.
Okay, let's start with the first S single.
Right. This dictates that you must focus your prompt on one well-defined task.
So I shouldn't go into Copilot and say, write a Python script that connects to an AWS S3 bucket, downloads all the CSV files, parses them for email addresses, and then uploads the results to a PostgreSQL database.
Yeah, that is a perfect example of what not to do.
It's too much, right?
Way too much. If you ask for the entire application architecture in one prompt, you're going to get hallucinated variables, mismatched logic, and unoptimized code. You've completely overwhelmed the model's attention mechanism.
So how do I fix that using the single principle?
Your first prompt should just be write a Python function using the Vodo3 library that authenticates to an AWS S3 bucket and returns a list of object keys. That is one task.
Okay, that makes sense. And that leads directly into the second S, which is specific. In my bad example, I just said connect to an S3 bucket. In your good example, you specifically mentioned the Vodo3 library.
Exactly. Being explicit leaves less room for the model to guess. Don't say write a function to process user data.
Be more detailed.
Right. Say write a function that takes an array of JSON objects, filters out any object where the age property is under 18, and returns a new array of strings containing only the email properties.
Wow, okay. The more constraints and technical specifics you provide, the higher the quality of the generated code.
Without a doubt.
But here's where I get a little tripped up by the third S, which is short. If I am being incredibly specific and detailing every single constraint of my JSON payload, how can I also be short? Doesn't specificity naturally create length?
It's a common misconception. It's really a matter of eliminating conversational noise, not technical detail.
Oh, okay.
You want to avoid overloading the model with irrelevant context. You don't need to write a narrative. You don't need to say, hey, Copilot, I'm working on this new feature for the marketing team, and they really need a way to filter these users. So could you please write a function? Yes.
Oh, I see. I need to treat it like a compiler, not a coworker.
That is a fantastic rule of thumb. Drop the pleasantries, just give it the rigid technical specifications.
Concise, dense, technical instruction.
Got it. And the final S in the framework is surround, which brings us right back to our discussion about FUM.
Yes, because FUM reads adjacent tabs.
So surround means I need to actively manage my IDE environment. Exactly. If you're writing a complex sorting algorithm for a custom user account object, but the definition of that user account object is closed, well, Copilot has to guess what properties exist on that object.
Right.
By opening the file that defines user count in the tab right next to your current workspace, you surround the model with the exact context it needs to write flawless code.
I love that. I am actively curating the workspace to manipulate the them. But let's be real. Even if I perfectly execute the single, specific, short, and surround method, the first block of code Copilot spits out isn't always going to be perfect, is it?
Honestly, rarely. And this is a major conceptual hurdle for developers who are transitioning to AI tools.
The expectation that it gets it right on the first try.
Yes. The exam material heavily emphasizes the difference between zero-shot learning and iterative prompting.
Okay, so zero-shot learning is when the model generates something entirely from its base training, right?
Yeah.
Without you providing any examples in the prompt.
That's right. Like if you ask it to write a standard function to convert Celsius to Fahrenheit, it just knows how to do that instantly.
But enterprise development is almost never zero-shot. We're dealing with proprietary business logic, custom middleware, unique architectural patterns.
Exactly. So when Copilot generates a complex function and it's, say, 80% correct, but misses a crucial piece of error handling, the absolute worst thing you can do is delete the whole block and start typing it yourself.
Which is my natural instinct. If it's wrong, I just want to grab the keyboard back and fix it manually.
You have to resist that instinct. The GH-300 wants you to use strategic iteration. You treat the prompt as a dialogue.
So if the output is slightly off, I don't rewrite the code. I modify my prompt.
Yes, you add a constraint. You say, update this function to include a try-catch block that specifically logs a connection timeout error.
You iterate on the English instruction, allowing the model to refine the syntax.
Exactly.
And there is a fantastic pro tip in the documentation for how you frame that instruction role prompting.
Oh, this is one of the most powerful ways to shape the model's output. By assigning the LLM a specific persona, you dynamically alter the internal weights of its attention mechanism.
So instead of just saying, write a function to validate a user's password input, which might just give me a basic regex that checks for 8 characters in a number.
Right, you use role prompting. You say, act as a senior cybersecurity engineer. Write a password validation function that strictly adheres to current OWASP security guidelines.
And just by adding that role, the model inherently prioritizes cryptographic best practices, salt generation, and protection against timing attacks.
Instead of just giving you the simplest possible code that compiles. Exactly.
Like putting a different hat on the AI. Okay, so we've established the mental framework for prompting. Now we really need to translate that into the actual physical interface of the IDE.
Yes, the GH-300 heavily tests your knowledge of where and how to interact with Copilot.
Let's map out the UI vocabulary, starting with the absolute most basic ghost text.
Ghost text is the passive, real-time autocomplete. As you type, the AFIM context is constantly updating, and Copilot offers suggestions as gray, italicized text directly ahead of your cursor.
It's designed for micro editions, right? You just press the tab key to accept it.
Or you just keep typing to ignore it. It's seamless.
It's brilliant for boilerplate or just finishing a line, but if I need to write an entire complex function, tabbing through ghost text line by line feels tedious.
It would be.
What if I want to prompt the model directly, but I don't want to lose my visual focus on the specific block of code I'm editing?
That is the exact use case for inline chat. You trigger it using a keyboard shortcut, typically Control on Windows or Command-I on a Mac.
This is the little prompt window that pops up directly over the code editor, right?
Yes, it hovers right where your cursor is. You type your prompt using the 4S method, of course, and Copilot will generate a diff.
Showing exactly what code it wants to insert or modify right there in the flow of the document.
Right. You can review the diff and accept it without your eyes ever leaving the center of your screen.
It completely eliminates context switching. But sometimes I actually need to context switch. Like if I'm trying to untangle a massive architectural mess, or I have a bug that spans 3 different files.
Yeah, a tiny floating text box isn't going to cut it for that.
Exactly.
For deep exploratory work, you move to the third interface, the Copilot Chat pane. This is a persistent, dedicated sidebar in your IDE.
Built for open-ended queries, architectural planning.
And long-running debugging sessions,
Yeah.
where you need to read extensive multi-paragraph explanations and review large blocks of generated code before deciding what to do with them.
And inside that chat pane, we have access to some incredibly powerful tools that the GH-300 will absolutely test you on. /commands and agents.
Let's start with /commands.
I see these as shortcuts for the most common developer intents.
They are exactly that. Instead of typing out, please read the selected code and write a comprehensive explanation of how the sorting algorithm works.
You simply highlight the code, open the chat pane, and type /explain.
And it breaks it down into plain English. It is an absolute lifesaver for onboarding into legacy code bases.
Oh, I bet. What are some of the other core /commands we need to memorize for the exam?
Well, /tests will automatically analyze the selected code and generate a suite of unit tests.
Nice.
And /doc will generate standardized documentation comments like JSDoc or XML documentation based on the function's parameters and return types.
I personally use /fix all the time. If my code is throwing an exception, I highlight the broken block, types /fix, and it not only tells me why it's broken, but it provides a unified diff.
Showing exactly which lines to change to resolve the error. It's incredibly efficient.
And don't forget /optimize, which is fantastic for performance tuning.
Oh, absolutely. It'll analyze your code for computational bottlenecks, like, nested loops that create O of n squared time complexity, and it'll suggest more efficient data structures or algorithms.
So /commands tell Copilot what action to take. But then we have agents, which are invoked with the @ symbol. And agents seem to tell Copilot where to look.
That is a very accurate way to conceptualize it. Agents direct your prompt to a specialized context engine, and the most important one for the exam is at Workspace.
Because normal Copilot chat, by default, is heavily focused on the specific file you just have open, right?
Correct. But if you type at Workspace, how is database authentication handled in this project? The agent bypasses that local file limitation.
It orchestrates a semantic search across your entire loaded repository.
Yes. It reads your configuration files, your middleware, your database schemas, and synthesizes a comprehensive answer based on the global architecture of your project.
That is staggering. It's like instantly downloading the entire repository structure into your brain. But my absolute favorite agent, and one that solves a massive pain point for me, is a terminal.
Oh, that's a good one.
Let's say I run npm install, and I get hit with a 50-line wall of red text because of some obscure C++ compiler peer dependency failure.
The worst.
Normally, I'd be copying and pasting snippets of that error into Google for an hour.
But with the @terminal agent, you don't have to leave the IDE. You just go to the chat pane and type @terminal, explain this error, and tell me how to fix it.
And the agent has direct access to the terminal buffer.
Right, exactly. It reads the raw output, identifies the specific missing dependency or environment variable causing the failure, and provides the exact bash command you need to run to resolve it.
It completely bridges the gap between the code editor and the execution environment. Okay, so we've covered the mechanics of prompting, and we know our way around the IDE interfaces.
Right.
But writing a script or fixing a compile error is just the microscopic day-to-day of a developer.
Yeah.
We need to zoom out. How does Copilot integrate into the macro level of a project?
We need to look at the entire software development lifecycle, or SDLC. The GH-300 expects you to understand how Copilot functions as a lifecycle assistant from conception to deployment.
Let's start at the very beginning of the
Yeah.
SDLC requirements analysis and design. Now, I assume Copilot isn't sitting in on stakeholder meetings taking notes on what the client wants.
Not yet, anyway. Human engineers still need to gather the business requirements and write the user stories.
But once you have a user story, say, as a user, I need to be able to upload a profile picture and crop it down. Copilot accelerates the translation of that story into technical architecture.
Yes, exactly.
How so? Can I just paste the user story right into the chat pane?
You can. You can use the chat pane to ask Copilot to generate rapid prototypes or initial API structures based on that high-level description.
So I can say, based on this user story, design the REST API endpoints and draft the JSON payload schemas for the image upload service.
Right. It helps flesh out the structural scaffolding before you write a single line of core logic.
It acts like an architectural sounding board. But where the exam really gets granular and where developers spend a massive amount of their time is the testing and quality assurance phase.
Testing is a critical competency for the GH-300. The official materials actually use a specific environment to illustrate this workflow.
Visual Studio Code, the .NET SDK, and the C# Dev Kit.
Exactly. We need to walk through how Copilot manages a test suite from absolute scratch in that environment.
Okay, stage 1 is setup. Let's say I have a brand new C# class library. I have written some business logic, but I have 0 tests, and honestly, I don't even have a testing framework installed.
In the past, you would have to manually create a new test project, manage the NuGet package dependencies, link the project references. It was tedious.
But with Copilot, I just open the chat view and use a specific /command, right, /setup tests.
Yes. So you just ask it to build the infrastructure.
And it does.
Copilot will analyze your workspace, recommend a standard framework like XUnit for a .NET environment, and then walk you through the setup.
It generates the terminal commands to create the project and add the packages.
And establishes the project references to your main code. It handles all the configuration boilerplate for you.
Okay, so the infrastructure is there. Stage 2 is generation. I need it to actually write the tests for my business logic.
This is where you combine tools. You open your C# class file, and in the chat pane, you leverage agent mode.
So I target workspace/tests, generate a comprehensive test suite for this file.
Right. And Copilot won't just write one happy path test. It will generate a multi-file suite that covers standard behavior, tests boundary conditions, and ensures exceptions are thrown correctly on invalid input.
It basically automates the drudgery of test coverage. But here is the reality of software development code changes. And when code changes, tests fail.
They always do.
Which brings us to stage 3, extension and repair. The exam expects us to know exactly which Copilot tool to reach for when things break. I like to think of this as choosing the right surgical instrument.
That analogy works perfectly for this. Let's say you just added a very minor new validation rule to a function, and you need to add a single new test case to your existing test file to cover it.
Okay.
The new test will follow the exact same structural pattern as the 10 tests above it. Which tool do you use?
For a minor, highly precise addition that follows an established pattern, I'm reaching for the scalpel. That is ghost text.
Exactly.
I'll just go to the bottom of the file, start typing the fact attribute and the name of the new test, and FAM will recognize the pattern of the file and autocomplete the rest of the test logic instantly.
Spot on. Now let's look at a different scenario. You are running your entire test suite inside the VS Code Test Explorer UI.
Okay.
Everything is green except one single test fails because you changed a string format in your main code. You want an immediate, hyper-focused fix for just that one failure without leaving the testing UI.
Right. I don't want to open the chat pane for that. I'm going to use the Fix Test Failure button that is integrated directly into the Test Explorer interface.
Correct. It's an immediate, single-test, targeted fix based on the exact assertion that just failed.
Awesome.
Now let's increase the complexity. A test fails, but the reason it failed isn't obvious. The failure is the result of a cascading architectural change you made across 3 different source files.
Right.
And the error output in the terminal is highly cryptic. What do you do?
Now I need to feed Copilot way more context, ghost text won't work, and the quick fix button doesn't have the scope.
Right.
I'm going to open the Copilot chat pane and use the /fixtestfailure/command. But crucially, before I hit enter, I'm going to manually attach those 3 modified source files and paste in the cryptic terminal output.
Exactly. You are managing the context window, so Copilot has the full picture of the crime scene.
And finally, the most complex scenario. You've pulled down a massive branch update, and suddenly dozens of tests are failing across multiple files.
This is a nightmare scenario.
You need to diagnose cascading failures across the entire architecture and apply synchronous fixes. That is, major multi-organ surgery. The scalpel won't cut it. I need the entire surgical team.
So what's the tool?
For this, I am invoking agent-driven test runs. I'm going to let the autonomous at workspace agent monitor the test executions, analyze the failures globally, and iteratively generate and apply fixes across the entire workspace until the suite turns green.
Perfectly stated. Knowing when to escalate from ghost text to the Test Explorer UI to the chat pane and finally to agent mode is a fundamental requirement for mastering the SDLC on the GH-300.
Okay, so we've engineered our prompts, navigated the IDE, designed the architecture, and executed the 3-stage testing workflow.
The code works perfectly on your machine.
But, it works on my machine, is a running joke in software engineering for a reason.
It really is.
Eventually, this code has to leave my laptop and be merged with the rest of the team's work. How do we take this code and safely push it into production?
We have to move out of the local IDE and head to the web. This is the transition to GitHub.com integration, pull requests, and code reviews.
Pull requests, or PRs, can be a massive bottleneck.
Yeah.
You finish coding, you are exhausted, and now you have to write a novel explaining what you did just so someone else can review it.
Copilot drastically accelerates this process. Once you push your branch and open a PR on GitHub.com, Copilot can automatically generate a comprehensive PR summary description.
Wow. Does it read the commits?
It analyzes the commit history and the code diffs and writes a detailed breakdown of the key changes, the files affected, the rationale behind the architecture, and it even formats the data into clean markdown tables.
It saves so much manual documentation time. It gives the human reviewer immediate, high-level context before they even look at a single line of code.
Absolutely.
But what about the review itself? Is Copilot going to replace my senior engineer who actually reviews my PRs?
The sources are extremely explicit about this. Copilot acts as a collaborative partner, not a replacement for human reviewers.
Okay, good to know.
During a code review on GitHub.com, Copilot can provide pre-submission quality checks. It can draft constructive review comments, clearly explaining issues and suggesting concrete code improvements in the form of inline patches.
Give me an example of that. What kind of issues is it spotting during a PR review?
It excels at spotting security vulnerabilities and anti-patterns. For instance, if you submit a PR for a JavaScript application, and the Copilot reviewer spots that you use the evil function to process a string of user input.
Oh, that's a massive red flag.
Exactly.
The evil function executes whatever string you pass it as code, which makes it incredibly vulnerable to code injection attacks.
Right. Copilot will instantly flag that line in the PR, draft a comment explaining the security risk of processing user input with evil, and provide an inline patch suggesting a safer alternative.
Like using JSON.parse if you were just trying to deserialize data.
Exactly. The PR author can then click a single button to accept the safer patch.
That is incredibly powerful for maintaining code quality. But here's the reality of enterprise computing. Nothing is free.
Very true.
Processing a massive pull request diff, analyzing it for security flaws, generating markdown tables, that requires serious compute power. How is this built?
This brings us to a crucial exam concept that you absolutely must memorize: premium request units, or PRUs.
PRUs, okay.
PRUs are the billing mechanics that organizations use to manage Copilot's advanced capabilities. The GH-300 requires you to understand the exact exchange rate of how different actions consume these units.
Okay, let's break down the PRU economics. What is the baseline?
The baseline is standard usage. When you use standard models like GPT-4o for basic code completion in the IDE, or simple single-turn chat queries, it costs approximately 1 PRU per request.
1 PRU for the daily lightweight tasks. When do we start burning more units?
You consume more PRUs when you invoke premium reasoning models. These are the models that power the complex GitHub.com features.
So like the PR reviews we just talked about.
Right. If you ask Copilot to analyze a 50-file pull request diff, perform a complex architectural review, or generate multiple different refactoring drafts for a single function, it requires a massively larger context window and significantly more computational reasoning.
How much does that cost?
Those premium requests consume roughly 4 or more PRUs per action.
That makes sense. It's doing a lot more thinking.
Yeah.
What about the autonomous agents we discussed earlier? If an agent is running my entire test suite and fixing things iteratively, how much does that cost?
Agent workflows operate on a draft and review loop. When one specialized agent plans a task and hands it off to another agent to execute the code, that multi-step reasoning process typically consumes 2 to 3 PRUs per step.
So if I'm an engineering manager, I can't just unleash premium reasoning models on every single spelling mistake in a readme file.
Definitely not.
I have to budget these PRUs. I have to balance the desire to have Copilot automatically review every single PR for style and security against our organization's overall PRU consumption limits.
Precisely. The exam tests your ability to manage resources, not just write code.
You've mentioned autonomous agents a few times, and we use them for testing, but I feel like it is time to dive into the deep end.
Let's do it.
Up until now, we're treating Copilot like a junior developer that we have to hold hands with. We prompt it, we review it, we click accept. Does it ever just do the work itself?
Yes. We are entering the domain of full autonomy, focusing on the Copilot Cloud Agent and the standalone GitHub Copilot app. This is a massive paradigm shift.
How so?
Copilot is transitioning from a passive assistant waiting for a prompt into an autonomous, asynchronous team member.
Asynchronous, meaning I don't have to sit there watching the cursor move.
Exactly. The Copilot Cloud Agent is integrated directly into GitHub Actions.
Okay.
You can go to an issue on your GitHub repository. Let's say issue 42 is a bug report about a misaligned CSS grid, and you can assign that issue directly to the Copilot Cloud Agent.
Wait, I just assigned the ticket to the AI.
Yes. And while you go get a coffee or start working on a completely different feature, the agent will independently create a new branch.
No way.
It will explore the repository to find the relevant CSS files, generate a step-by-step implementation plan, draft the code changes, and open a pull request for you to review.
Okay, that is incredible, but my security alarms are absolutely blaring right now.
I figured they would be.
You are telling me there is an autonomous AI out there that can read my code, create branches, write logic, and open PRs while I'm not even looking. If a bad actor got access to that, they could inject malicious code into my entire architecture.
And that is exactly why the exam is going to heavily test the security guardrails for this. It is arguably the most important part of the autonomy module.
Okay, lay out the rules for me.
The Copilot Cloud Agent operates under 4 rigid, non-negotiable security rules that you must memorize. Rule 1 revolves around access control.
Who can use it?
Right. The agent only responds to interactions from users who already have explicit write access to the repository. A random open source contributor cannot trigger your agent to alter your code base.
Rule 1, write access required. That stops random internet trolls. What about the execution environment? Where is this agent actually doing the work?
Rule 2, sandboxing. The agent runs inside a highly restricted, firewalled GitHub Actions sandbox.
Okay, so it's contained.
Yes. When it is analyzing the issue and planning, it only has read-only access to your repository. Furthermore, its internet access is firewall restricted by default to prevent it from accidentally exfiltrating your proprietary code to an external server.
Rule 2, firewalled sandbox. So it drafts the code in a safe space. Where is it allowed to push that code? Could it just push a broken fix straight to production?
Absolutely not. Rule 3, branch restrictions. The cloud agent is strictly limited in where it can push commits.
Let me guess, it can't push to main.
Correct. It can only create and push to branches whose names begin with the prefix copilot/. It is architecturally blocked from ever pushing directly to main, master, or any protected release branch.
Rule 3, restricted copilot/branches only. And finally, if it opens a pull request from that branch, can it just merge its own PR?
Rule 4, separation of duties. The agent can never approve its own pull requests.
Oh, yeah.
In fact, if the agent's PR includes updates to GitHub Actions workflow files, those workflows will not even run until a human with write access explicitly clicks an approval button.
So a human always has the final say.
Always. And crucially, the human who originally assigned the issue to the agent cannot be the sole approver for the PR. It respects all existing required reviewer rules configured for your repository.
Write access required, firewalled sandbox, restricted branches, and strict separation of duties. Got it.
Excellent.
Now, alongside this cloud agent operating in the background on GitHub.com, the sources also talk about a brand new standalone GitHub Copilot app.
Yes.
If I already have Copilot in VS Code and I have it on GitHub.com, why do I need a separate application on my desktop?
Because modern development suffers from immense context switching friction. Think about your current workflow. You read an issue in your browser, you switch to your terminal to pull the branch, you open your IDE to write the code.
Then you go back to the terminal to run tests and back to the browser to open the PR. It's a constant alt-tabbing nightmare.
Exactly. The standalone Copilot app, powered by the Copilot CLI runtime, brings all of that into one unified interface.
Oh, wow.
You can track an issue, instruct the agent to write the code, review the diffs, run the tests, and merge the pull request without ever changing windows.
And inside this app, you dictate how much leash you give the AI.
Right.
There are 3 distinct session modes that define the agent's autonomy.
Correct. The first is interactive mode. This is highly collaborative and cautious. The agent proposes a single change, explains its reasoning, and then pauses.
It will not proceed to the next step until you explicitly click approve.
Right.
That sounds perfect for exploratory tasks where I'm not entirely sure how I want to solve the problem yet, and I just want to guide the AI step by step. What is the second mode?
Plan mode. In this mode, the agent analyzes the issue and creates a highly detailed, comprehensive roadmap of all the files it intends to touch and the logic it intends to implement.
So it shows you its homework.
Essentially, yes. It presents this entire master plan to you for human review and adjustment before it writes a single line of code.
Measure twice, cut once. I'd use plan mode for complex architectural refactoring. You make sure its underlying logic is sound before it rewrites 50 files. And the final mode.
Autopilot mode. This is full, unbridled autonomy. You give it the issue, and the agent works completely independently. It implements the changes, it actively runs your test suite, and if a test fails, it iteratively reads the error and fixes its own code until the tests pass,
It completes the entire task with zero human intervention.
resulting in a perfectly green, ready-to-review PR.
You really have to have an ironclad test suite to trust autopilot mode.
Huh?
Okay, we've covered the IDE, we've covered the web, and we've covered the standalone app.
But there is a massive demographic of power users who spend half their lives staring at a black screen with green text.
The command line warriors. We need to talk about the command line interface. How does Copilot help us in the terminal?
The terminal is incredibly powerful, but it relies heavily on rote memorization, remembering the exact bash syntax for piping outputs, constructing complex regex statements, or remembering that one obscure Git command to untangle a botched rebase is just tedious.
So true.
The Copilot CLI, which you invoke by typing G Copilot, eliminates that friction.
The exam highlights two primary commands for the CLI: explain and suggest.
Right. Let's say you inherit a server and you find a dense, incomprehensible bash script full of awk and sed commands that looks like absolute gibberish.
In there.
You can type G Copilot, explain, and paste the command. The AI will break down exactly what every single flag and pipe does, step by step, in plain English.
It translates machine code into human intent. And suggest does the exact opposite, right?
Yes. If you know your intent, say, I want to find all PDF files in this directory that were modified in the last 3 days, zip them into an archive and move them to a backup folder, but you have no idea how to write that bash loop.
You just type G Copilot suggest, followed by your natural language intent.
Exactly. It translates your English into the exact executable terminal command. You can run this in interactive mode just by typing Copilot, which gives you a persistent chat session right there in the terminal.
Or you could use one-shot mode with Copilot-I for a single immediate answer.
Right.
But wait, if I'm asking the Copilot CLI to suggest and execute commands that move files or alter network configurations, is that safe? Could it accidentally suggest remove -rf/ and wipe my entire hard drive?
That is a critical safety concern, which is why the Copilot CLI utilizes sandboxing. The GH-300 expects you to distinguish between two types.
Okay, what are they?
Local sandboxing executes the suggested commands inside a highly restricted, isolated environment on your actual physical machine. It can test the logic without accessing your core system files.
And the other type?
Cloud sandboxing. That provides a completely remote, secure execution environment, protecting your local architecture entirely while still allowing the agent to validate the command.
Okay, now we are arriving at what I think is the most exciting paradigm-shifting technology on the entire GH-300 syllabus. This is the piece that changes everything about how AI integrates into our tools.
Ah, yes. The Model Context Protocol, or MCP.
MCP is a foundational architectural breakthrough. Prior to MCP, getting an AI model to talk to an external data source was a nightmare of bespoke engineering.
Oh, it was awful.
The official text explicitly calls MCP the USB-C standard for AI tools. Absolutely love this analogy. Let's build on it.
Please do.
Before USB-C, you needed a different proprietary cable for every device you owned. You had a micro USB for your phone, a mini USB for your camera, and a proprietary brick for your laptop.
Right.
In the AI world, if you wanted your LLM to query a local PostgreSQL database and also fetch data from a Jira API, you had to write custom API wrappers, spin up dedicated Docker containers, and manage brittle manual configuration files for every single tool.
Exactly. It was a completely fragmented ecosystem. MCP replaces all those proprietary cables with a universal, standardized, secure protocol. It allows AI models to connect to external tools and data sources seamlessly.
And for the exam, you must understand the architecture of the three primary MCP connection setups. Let's break those down. Setup 1, local to local.
In a local-to-local setup, an MCP client, which would be Copilot running in your desktop instance of VS Code, talks directly to a local MCP server running quietly in the background on your machine.
And that server is hardwired into your local data. like a local SQLite database or your specific file system.
Yes, so you can open Copilot Chat and say, write a SQL query to find all active users, and because of the local MCP server, it actually knows the exact schema of your local database without you having to copy and paste it into the prompt.
And because it's all local, it's incredibly fast and entirely private.
Precisely. Setup 2 is local to remote.
Okay, how does that work?
In this architecture, your local Copilot client connects to the local MCP server on your machine, but that server acts as a secure bridge to a remote service on the internet, like an AWS API.
Why not just connect the client directly to the internet? Why use the local server as a bridge?
Because the local server acts as a governance layer. If your tool needs to fetch massive amounts of data from an external API, you want your local MCP server to handle the caching, the API key authentication, and the data pre-processing.
Ensuring that only the relevant sanitized data is fed into the Copilot context window?
Exactly.
That makes perfect architectural sense. And setup 3, remote to remote.
Here, the Copilot client connects to an MCP server that is hosted entirely in the cloud, which in turn communicates with other massive web services. You use this when the computational heavy lifting or the security requirements of the sauce integration cannot be handled on a local developer's laptop.
And the crown jewel of all this technology for GitHub users is the GitHub MCP server.
Yes. Historically, setting up even a local MCP server required a bit of DevOps work managing Docker instances and JSON config files. The GitHub MCP server completely eliminates that friction.
How so?
It is a fully managed remote server that you connect to with a simple one-click OAuth login.
And what superpower does connecting to that GitHub MCP server actually give me inside my IDE?
It gives Copilot Chat seamless, real-time access to your entire remote GitHub ecosystem. You can be writing code in VS Code and type, summarize the discussion on issue 105, and draft a function to address it.
Wow.
The MCP server securely reaches out to github.com, reads the issue comments, and feeds that context directly into your IDE prompt.
It allows the AI to perform semantic searches across remote repositories, triage issues, and manage pull requests, all via natural language, without ever leaving your editor.
It transforms the IDE from a simple text editor into a universal command center.
We're in the home stretch of the GH-300 masterclass. We have covered the micro level of FIME, the local SDLC, the macro level of GitHub PRs and agents.
But there is one final domain.
Right. It is one thing for a single developer to use Copilot effectively. It is an entirely different operational challenge when a chief technology officer decides to roll this out to 10,000 engineers across a global enterprise.
We need to talk about administration, governance, and responsible AI.
Governance is critical, and the exam will test your knowledge of the different subscription tiers and the administrative controls they offer. Let's start with the baseline free, Pro and Pro Plus.
Those are the individual tiers. They give you the core coding assistance, but they have individual usage limits. And the Pro Plus tier gives you priority access to the latest models during times of high server demand.
But if I'm running a company, I need centralized control.
That is where you upgrade to the Copilot Business Plan. This introduces centralized policy management. Administrators can enforce rules across the entire organization.
And crucially, the business tier ensures that all organizational data, your prompts, your FEM context, your proprietary code, is strictly excluded from Microsoft's public model training by default.
Right. That is the table stakes for enterprise adoption. But the business plan also introduces a concept that I know developers ask about constantly: IP indemnity.
This is huge. Let me pose a very common compliance scenario.
Go for it.
Let's say one of my junior developers is stuck, and Copilot generates a 50-line block of complex cryptography code. The dev accepts it. A year later, we find out that exact 50-line block was identical to a copyrighted, tightly licensed open-source project. Are we going to get sued for copyright infringement?
This is exactly what GitHub's IP indemnity is designed to address. IP indemnity means that if a Copilot suggestion is challenged in court as infringing on third-party intellectual property, GitHub assumes the legal responsibility and the legal defense costs, not your company.
Wow. Microsoft and GitHub shield the customer legally. That is a massive safety net.
It is, however, and this is a critical exam detail that traps many people. GitHub only assumes this legal responsibility under one strict condition.
What's the condition?
The organization administrator must have explicitly blocked the matching public code setting in the centralized policy control.
So there is an actual toggle switch.
Yes.
If you turn that setting on, Copilot actively filters out any generated suggestion that matches roughly 150 characters of publicly available code on GitHub.
Right. If you use the filter, GitHub protects you legally. If you turn the filter off and allow matching public code into your code base, you are on your own.
It is a vital compliance toggle that balances developer freedom against legal risk. Now, above the business tier is the enterprise tier. What additional power does enterprise get?
Copilot Enterprise includes all the governance and indemnity of business, but it adds deep architectural integration with GitHub Enterprise Cloud.
Okay, what does that mean in practice?
It enables the AI to perform semantic code-based searches across the organization's massive private repositories. But the most significant feature is fine-tuning.
Fine-tuning the model itself.
Yes, Enterprise allows organizations to train and fine-tune custom Copilot models strictly on their own private proprietary codebase. This results in highly personalized, company-specific code suggestions that understand internal frameworks perfectly.
To wrap up our masterclass, we have to look beyond the technology and look at the ethics. Microsoft and GitHub operate under a specific, formalized framework called the 6 Principles of Responsible AI.
And if you are taking any Microsoft certification, you will be tested on these.
Let's list the 6 pillars.
The 6 principles are fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability.
Let's focus on how the last 2, transparency and accountability, specifically apply to the daily life of a developer using Copilot. How is a code generator transparent?
Transparency means the AI system must be understandable to the user. It shouldn't be a black box of magic that spits out code without explanation.
So what does that look like in Copilot?
For Copilot, transparency means providing clear validation frameworks. It means the UI must acknowledge the limitations of the LLM. Copilot will explicitly warn you that it might generate insecure, suboptimal, or hallucinated code, and it provides tools like the chat pane to let you query its reasoning.
Okay, and what about accountability?
Accountability is the most important principle of all. It dictates that humans are ultimately responsible for the outcomes of AI systems.
Because Copilot is a powerful assistant, but it is not an autonomous employee.
Exactly. A human developer must review, validate, and test all AI-generated code before it is ever deployed to production.
So you cannot sit in a post-mortem meeting after a massive production outage and say, well, Copilot wrote the bug, it's not my fault.
No, you definitely cannot. The human engineer is accountable for the output, not the machine. The AI suggests, but the human decides.
Well, you have survived the comprehensive GH-300 masterclass. We have journeyed from the exact millisecond FAM tokenizes your prefix and suffix through the rigid 4S method of prompt engineering.
We've navigated the ghost text and inline chat, orchestrated a full C# testing lifecycle,
Debated the economics of premium request units, unleashed the autonomous Copilot cloud agent under strict security guardrails.
wired up the MCP architecture, and established enterprise-grade governance.
It is a phenomenal amount of material to synthesize. But as you walk into that testing center, remember this. While the exam tests your memorization of configurations and routing architectures, the true value of mastering Copilot isn't just getting a passing score.
It really isn't. It is about fundamentally reducing your cognitive load. It's about letting the AI handle the boilerplate syntax, the rote test generation, and the documentation.
So you can preserve your mental energy for the deep creative flow state of actual software architecture.
Exactly.
And that leaves us with one final provocative thought to mull over as you prepare. As we look at tools like the Copilot Cloud Agent and these autopilot modes that can take an issue, explore a repo, write the code, run the tests, and open a PR while you drink your coffee, the fundamental role of a software engineer is shifting beneath our feet.
It really is.
If the AI is increasingly the one doing the actual typing, does the developer of tomorrow become less of a traditional coder who memorizes syntax and more of an editor and orchestrator of a team of autonomous agents?
That's the big question.
If your job is no longer writing the code, but evaluating the logic of the machine that wrote it, what will your daily life actually look like in 5 years? It's something to think about. Thank you for taking this deep dive with us, and good luck on the exam.